Welcome to this video where we're going to learn how to build an MCP server in Python and then connect it to Claude Desktop so that we can use it as an AI agent. If you haven't heard of the term MCP before, it stands for Model Context Protocol, and it describes itself as a USB-C for AI applications. Instead of building one-off integrations for everything, MCP provides a standard way for AI models to connect to anything where you'd normally use a REST API. This is very important for building autonomous AI agents because any tool or data source that you want your agent to have will probably need to have an MCP server. Here's a quick demo of the project that we'll be working on. I have two custom MCP tools that I've connected to my app. First, there's a tool that can fetch the current weather for a city, and another tool that can create and modify spreadsheets in my Google Drive folder. The first tool is implemented ourselves in Python, and this will live locally on our machine. The second tool is a third-party implementation that we're just going to set up. And with both of these tools set up, I can give my agent instructions, like to get the current weather for all cities in Australia and put them into a Google Sheet for me. And then the agent is going to think for a bit and then use these MCP servers with the right parameters to get the information that it needs. And it doesn't just retrieve information, it can also do things like creating spreadsheets and updating the spreadsheet in my Google Drive folder as well. And here's the result. This is a Google Sheets that our AI agent created for us by leveraging both of the two MCP servers that we've provided it. In this video, I'll walk you through how to build your own MCP server from scratch using the official SDK for Python. For this project, it will just call an API to fetch the weather. But generally, this is a useful thing to know if you want to build custom MCP servers for your own service. Next, we'll look at how to set up a Google Sheets MCP server. This is an existing third-party integration that has already been developed by someone else. So we're just going to learn how to set it up and how to use it. Finally, we'll finish up by connecting everything to Claude Desktop so that you can test and use all of these tools together. All of the code is available on this GitHub repository, and the link is in the description if you wanted to take a closer look. Also, if you need an introduction or a refresher to MCP, then check out my previous video where I go through it in a little bit more detail. It's only 15 minutes and the link is in the description. But if you're ready, let's get started. Before we get into the code, let's first take a high-level look at what we'll be working on. MCP uses a simple client-server architecture, just like traditional REST APIs. And here's a very simplified diagram describing that. On one side, you have MCP clients. These are AI applications like Claude Desktop or Cursor. On the other side, you have MCP servers. These are the tools and the data sources that you want your AI to be able to access. Implementation-wise, MCP servers are basically just tiny programs that can run anywhere. It can run remotely or it can run locally on your system. In this video, both of the MCP servers we're using will run locally on our machine. The MCP server will be the one to communicate externally with those APIs. The server itself is local. Now, by setting this up, what this means is that you'll be able to chat with your AI agent like normal, but now it has these tools available, so it'll be able to do things that an LLM model wouldn't normally be able to do by itself. Things like checking the current weather or creating and updating a spreadsheet in your Google Drive. You can probably imagine that with the right set of tools, an AI agent can be very powerful, especially if you consider that it can use all of these tools together. Now, the whole idea behind MCP is that any client can talk to any server as long as they both follow the MCP protocol. And it doesn't even matter what programming language it's implemented in. So if you build an MCP server today, it will work with Claude Desktop, but it will also work with any other MCP compatible client out there or ones that come out in the future. MCP servers expose three main types of capabilities. Tools are functions that AI can call to perform actions, like getting weather data, sending emails, updating a spreadsheet. Resources are data sources that the AI can read from, and these can be files or databases. And prompts are templates that help the AI use tools and resources more effectively. In today's example, we're just going to build a single tool called getWeather. The AI will be able to call this tool to get real-time weather data for any location, and this is just going to use the OpenWeather API. First, we'll need to set up a project environment. I recommend using UV for Python package management since it works really well for this type of project. You can just run these commands in the project after you've cloned it. Next, you need to get an API key from OpenWeatherMap. So head over to their website, openweathermap.org and sign up and then click Create an API key. Then once you have the key, you could just set it as an environment variable like this. Now, if you had cloned the project and run the command to set it up, then one of the dependencies you've installed is the official MCP Python SDK. But if you didn't set it up that way, you can go to this website and follow other instructions on how you can install this dependency. This is what we're going to be using to create our MCP server. And here is a truncated snippet of what the actual code will look like. It's just a one-liner here to create a fast MCP instance. And this is going to be the server that will host all of our tools, resources, and prompts. So one server can actually host multiple of these capabilities. Then we'll use this mcp.tool decorator on any function that we want to expose as a tool. Fast MCP will automatically read the function signature and its docstring to understand what parameters the tool needs and what the tool does. So our AI will know that this tool takes a city name and returns weather information. And if your tools has any dependencies, you can also specify them with the dependencies parameter like this one. Here we need the request library because we're going to be making a HTTP request to fetch the weather via that API. And this just makes sure that when we configure or set up the MCP server, that it prepares all of these dependencies for us in the Python environment that the server will run. Now here's a truncated version of the actual function code. So this fleshes out the function a little bit, but the whole function itself is still pretty straightforward. We basically just use the OpenWeatherMap API to first get the coordinates for the city, and then we use those coordinates to fetch the weather data. And then we return a simple dictionary with the location, the temperature, and the weather description. Again, really simple stuff. But the point of all of this is that any code you can write with Python can easily become an MCP tool. So you can use this to write your own custom logic, use any dependency that you need, or even call an API like we're doing here. And then you can choose whether you want to return your results as a dictionary, like we're doing here, or just as a text string. Now that we've written all of this up, there's a really easy way to test this as well, using something called an MCP inspector. You can start it by running this command. So now let's pop over to the code editor and actually see the project in action. So if you've cloned the project, you should have this MCP weather server Python file over here in the source directory. And here's all the code that we looked at, except that it's got a little bit more details. The important thing is remembering to set the API key in the Python environment you will use to run this. And another important detail is that we have a command to run this MCP server if this file is the entry point for our application. Okay, so now let's go over to the terminal and run this command to bring up the development server. And here it's started the server and it's got a session token to authenticate us. You have to click this authenticated link here, not this one here, because this one won't have the token. So click this one here and you'll see this web UI open up so that we can test our server before we connect it with anything else. Press this button to connect the server. And here you can see it's connected and we've got resources, prompts, and tools. Now we only created a single tool, so we're going to expect it to show up here. So if you press list tools, you'll see that we have this get weather tool show up. And if you click on it, we can try it out. We can put in the name of a city that we want, for example, Tokyo. And here you can see the results. The tool call was a success and the temperature in Tokyo right now is 29 degrees and it's cloudy. And this is really good because you could basically use this whole thing to debug the server as much as you want before you plug it in as part of a bigger workflow. Now let's take a look at something a little bit more complex, connecting your AI to Google Sheets. Spreadsheets are something that people work with all of the time, and it's going to be super useful for us to have this as part of our AI workflow. For a lot of popular external tools out there, chances are that there's already an existing MCP server that someone else has created, and we can just use it. Go to this Model Context Protocol server's GitHub page if you want to take a look at a collection of all the MCP servers currently available. More and more are coming out every day, so this list is only growing. And for the case of Google Sheets, I found this really great third-party server created by somebody named Xing Wu, so thank you, Xing. So that is what we'll use. I'll post the link to this in the description as well. And all of the setup instructions are listed here in the README. So we'll follow that in order to set up Google Cloud and then everything else we need to run this MCP server. And as you can see, the easiest way for us to run this is using the UVX command. this will automatically download and run the latest version of this MCP server for us. And this is pretty much why I think it's currently better to use UV as a package manager over pip at the moment. If you're working with MCP servers right now, then you don't have to set up your own environment or anything. You can just run this command and it'll be able to download and manage that environment for you. But before any of that works, we'll need to set up Google Cloud credentials so that the tool can have access to our Google Sheets. And this is going to be the most complex part of the setup, but I'll walk you through that step by step. First, go to the Google Cloud Console and create a new project or select an existing one. You'll need to enable two APIs, the Google Sheets API and the Google Drive API. So it's pretty simple. All you have to do is just search for those in the toolbar at the top and then click to enable it. So make sure that you see this API enabled check mark, and then go back and then do the same for the Google Drive API. Make sure that this one is enabled as well. Next, we'll need to set up some authentication. We'll use a service account here because it'll give us a long-lived credential as a JSON file that we can provide to our MCP server. So to do that, go to the search bar and search for IAM. Then click on IAM and admin. And in the tab to the left, click on service accounts. And here you could see the account that I've previously created for this tutorial. But if you're new, then just click create service account at the top. Put in the name that you want. So fill both of those in and then click create. And then for the role here, search for editor. This is the one we want to use. If you want it to be more secure, you can give it very specific roles as well. This takes a bit more time, so we're just going to go with this for now. Then we'll click continue. Now, once you have the account, you can click these three dots on the Actions tab and go to Manage Keys. And then click Add Key and Create New Key. And you can create a JSON key. So click Create. And after creating this key, it will save a JSON file to your computer. And it says here, it allows access to your cloud resources, so store it securely. So this is very important to keep this private, but we will need to use this for our MCP server. So move this to a secure location and remember the path because we're going to give that path for our MCP server to access. The final step is to create a shared folder in your Google Drive. Create a new folder, you can name it whatever you want, and then share it with your service account email address. So click this button to share it, and then get your service account email address, which if you go back to your IAM page on Google Cloud, you'll be able to find it under service account details, and it's here under email. So copy that email, paste it in here, and make sure that it has the editor role. And once that's done, click save, and your setup should be ready. Now, you'll also need to copy this folder ID. So this is the part of the URL here. That's just a bunch of numbers and letters. This is going to be the ID for your Drive folder. So copy that because we're going to need that later. The two environment variables that you will eventually need for your MCP server is going to be the path to your service account JSON file, the one that you saved earlier, and then that Google Drive folder ID. Don't worry about setting that up yet. We'll do that in the next step. Now comes the fun part, actually using these tools with an AI agent. Any MCP compatible clients will work with the tools that we just looked at. But for this tutorial, we'll use Claude Desktop because it's easy. Claude Desktop has inbuilt MCP support, which means that we can connect our servers directly to it. And we just need to edit the configuration file to tell Claude about our servers. On Mac, the config file is located in application support, which is this path you see here on the screen. On Windows, it's in your app data folder. And here's a code snippet of what that configuration looks like. As you can see, we use the UV command again because it does a really good job of managing our environment for us. And because this MCP server code exists on our machines, we'll also need the absolute path to that server file. And in this snippet, you can also see how we pass in environment variables, like the API key to the server. Now, what this configuration will do is that when you start Claude Desktop, it will run this command with these arguments to start up an instance of your MCP server locally on your machine. So this will be a separate process that's just running alongside Claude Desktop. And then it'll be available for the AI to use when you chat with it. For the Google Sheets folder, the setup is also very familiar. But what's cool is that we can just use UVX to run this package for us directly without having to download or install it first beforehand. It's just really simple. And again, we'll need some environment variables here as well. So replace these with the path to your service account JSON and the ID of the drive folder that you created earlier. Now, if you're in the Claude Desktop app, there's another way you can access this folder, which is if you go to Claude and then go to Settings, and then in Settings, go to the Developer tab, and here you'll find all your connected tools and a button to edit the config. So if you click on that, it'll take you to the folder where the config file is directly. And then you can open that up in VS Code and put in your config JSON there. So this is what my config file currently looks like with both of these tools added. Now, another cool thing is that if you're developing this tool locally, like we are with this MCP Server app, then instead of configuring the JSON by hand, there's actually a command you can run, which is MCP install server, and just replace this with whatever the file name is. And this will basically set up the config for us based on what it knows about this file. After you've saved your config file, you should be able to just restart Claude Desktop and then see the tools come online. If they don't work, you'll see an error message and a link to logs on how you can debug them. But in this case, our tools should work and be connected to our app. And if you open this Tools and Integrations tab, you'll be able to see them appear down here. And if you click into them, you could see all the different tools that are available for this MCP server. So our weather MCP server only has one tool, which is to get the weather. You can disable or enable it. And then the Google Sheets MCP server actually has a lot more different tools. So things like getting the sheet data, updating rows, updating columns, that kind of thing. Now with these tools set up, Claude is kind of like an AI agent that has more capabilities. So now we can ask it, for example, what's the weather like in Tokyo? And here it has figured out that it should use this get weather tool. It's also figured out what the request should look like. So this is all figured out by that MCP protocol that we defined for this function. It calls the tool calls the weather API, and now we get the results. And this is kind of all hidden away as part of an internal process. At the end of the process, the agent is able to respond to us with this response. Similarly, we can also test out that the Google Sheets tool works. So I can say here, create a new spreadsheet with 10 movie recommendations.
Right.
And once that's completed, we can go back to our Google Drive folder and see that it's created the spreadsheet for us and has filled it in. The really cool thing is that Claude can understand what tools are available and when and how to use them just based on natural language. You don't have to remember specific commands or syntax. You can just ask what you want in English, and it will figure out how to use the tools and how to combine them as well. So for example here, let's say that I'm going to go on holiday to London and then Bangkok for a week each, and I wanted to get the weather there so I know what I should pack. And here it's fetched the weather for both locations currently and recommended me that I need something that can transition between both cool weather and tropical heat. And of course, I can combine the use of tools as well, so I can get it to fetch the weather for a bunch of different locations and then put that into a spreadsheet like in the demo at the start of the video. This was a fun and simple project, but I think it's still really just the beginning of what AI agents will be able to do. There are already hundreds of MCP servers out there and more coming online every day. Now, as always, the code for this project is available on GitHub and the link is in the description. If you enjoyed this video and you want to see more tutorials on MCP, AI agents, or automation, then do let me know in the comments what type of topics you'd be interested in. I also don't do any kind of sponsors or affiliates on my videos, so subscribe to this channel if you want to see more content that puts you as the viewer first. Otherwise, I hope you found this useful and see you in the next one.